Hi, this is Dr. JMR, JMR Chemistry. Today I would like to explain about ionization energy. Here, ionization enthalpy or ionization energy or ionization potential all are same. So here, ionization enthalpy is very important. It is crucial for predicting chemical behavior, determining valence electrons, understanding periodic trends. Means this ionization energy plays a major role in a bonding and a chemical reaction, everything. So here it is governed by, depends on nuclear charge, electron shielding effect, atomic size, electron repulsion. We'll go through with the definition. The amount of energy required to remove an electron from outermost shell. See here, we are removing one electron from the outermost shell. Removing of that electron, naturally some attraction takes place from the nucleus to outermost shell. Removal of one electron from the outermost shell. That energy is known as ionization potential. So here the strength of attraction between the nucleus and outermost shell, it depends on shielding effect. How many orbits are there? It depends on the attraction between nucleus and outermost shell. The units for this ionization energy or enthalpy, kilojoules per mole or electron volts. We'll go through the one example. I would like to explain with an example. Sodium atomic number is 11. Here electronic configuration is 1s2, 2s2, 2p6 and 3s1. Here valency shell contains only one electron. Means, is it stable? No, because according to octet rule, if valency shell contains 8 electrons, that is stable, but it contains only 1 electron. Means it is ready to accept 7 electrons? No, because that much energy is means more energy is required. So that is why it is ready to donate. Means sodium valency shell contains 1 electron. By donating this electron, what happened? This will become what? A stable. So that is why sodium minus 1 electron, it required some energy. That is called, you are removing 1 electron now. That is called first ionization potential. And after donating, this sodium atom will become sodium ion. This is stable? Yes. Why? It obeys octet rule. Means a valency shell contains 8 electrons. Here it contains 8 electrons in the valency shell, so that is why stable. Sodium ion is more stable than sodium atom because it contains 8 electrons in the valency shell. So here, okay, we required we required 495 kilojoules per mole. That much energy is needed for the removal of one electron from this sodium atom. Removal of one electron. Okay, 495 kilojoules of energy is required. Then after converting to Na plus, again you are removing one more electron. Means Na plus is converted to Na plus 2. Means you are removing one more electron. Here very important, what is that? More energy is needed. How much? 4,562 kilojoules of energy is needed. Means the difference between first ionization potential and second ionization potential, a huge difference, because Na plus is more stable and it obeys stable electronic configuration. So that is why what happened, we required more energy for the removal of another electron, is nothing but second ionization potential. Here Na plus is stable. Why it is stable? Because it contains 8 electrons in the valence shell, and Na plus 2 is unstable. Why it is unstable? Means it contains 7 electrons in the valence shell. We removed one more electron. Sometimes you will ask, among these two, which one is more stable? Then you have to say Na plus is more stable than Na plus 2. So we'll go through another example. Lithium, naturally it contains only one electron in the valence shell. So removal of first electron, we can call it as first ionization energy. So here, by removing one electron, it contains only two electrons. Why? First orbit capacity only 2. According to doublet electronic configuration, it is stable. So we required 520 kilojoules per mole. It is required. Removal of first electron. This much energy is needed. So here, removal of second electron. This is called second, what do you call, ionization energy or potential. Here what happened? 7298 means more energy. Why? By removing one electron, it will become stable. See here, by removing this electron, according to doublet electronic configuration, this is stable. Again, removal of one more electron from the stable, more energy is needed. This is very, very important. Suppose you take magnesium. It contains two electrons. Indirectly, removal of two electrons is very easy, and removal of third electron from this, it is very difficult. Why? By removing these two electrons, it will become stable. Similarly, with example, first ionization energy means removal of what you call one electron. See here. So one electron we removed. We required 737 kilojoules of energy per mole, and removal of second electron from Mg plus 1. Then naturally we required only 1451 kilojoules. Removal of third electron, I told just now. Here removal of two electrons, it is very easy. These two require less energy. But removal of third electron means removal of one electron from 2p, more energy is needed. Based on this, we can identify which is what is that stable. Indirectly, less energy is required means we can remove. More energy means you required, means that is a stable atom, more energy is needed. Sometimes he will give you the energies, then you have to identify. Then we'll see aluminium. Here you see removal of three electrons are very easy, because after donating the three electrons, it attains stable electronic configuration. So first, second, third, it is less, but removal of fourth electron is very difficult, because according to octet rule, means it is very difficult to attract five electrons. So that is why it is ready to donate these three electrons. See. So first ionization energy means removal of one first electron, 577 kilojoules of energy is required. Removal of one electron from aluminium. Again, removal of what you call a second electron from Al plus 1 means unipositive ion. So 1000, what you call 817 kilojoules of energy is needed. Removal of one more electron means removal of one more electron, so naturally 2745 kilojoules of energy is needed. Removal of, see here, removal of, this is very, very important, removal of what you call one more electron, removal of one more electron, we required 11580, means three electrons, removal of three electrons, it is very easy, removal of fourth electron is very difficult. Suppose we'll go through that one more electron. So here removal of 4 electrons easy. So removal of fifth electron is very difficult. So that is why here what happened, first ionization energy, that is 700 and removal of one electron, 786 kilojoules of energy, and second one, removal of second electron is 1577 kilojoules, and third ionization energy is 3232 kilojoules of energy, and removal of fourth is also what you call, it is very easy. See here, fifth one, it is very important. Fifth electron, whatever more energy, that is 16,090 kilojoules of energy. See here, removal of first, second, third, fourth, then it is very easy. But removal of last electron is very difficult. Means indirectly removal of four electrons are easy, but fifth electron is very difficult. Suppose you take phosphorus, same removal of, so here what happened, suppose ionization energy, so generally it is attracting, so here, but if you'll remove, generally he will give you, if you'll remove electron, first electron, second electron, third electron, then fourth electron, fifth electron, see here, sixth electron, how much energy is needed, 21,270, means that much energy is needed in terms of ionization energy. So like that, here what happened, this is what high energy means, indirectly after removing these five electrons, generally it will attract, but just in terms of ionization energy I am telling. So after removing these five electrons, so here what happened, it will become stable electronic configuration. So like this ionization energy, so you're having one graph here. So here hydrogen, then like this type of what you call, how the ionization energy, what based on the atomic number in different terms, we can see how it is increasing or decreasing, like this. So here first ionization energy, second, see, so huge difference is there between what is that stable electron, removal of stable electron, that is very very important. Suppose here ionization energy, naturally it influenced by nuclear charge. Suppose here nuclear charge is higher charges, naturally stronger pulling of electron. It depends on what you call nuclear charge and shielding effects. Why it shields? So orbital shields. Why here what happened? Nuclear and outermost shell, some amount of energy is less energy is required. So it depends on what a number of orbits and atomic size and electron repulsion. It depends on what you call these factors. This is very important across period, from left to period, means this is very important from left to right. So what happened, ionization energy increases, this is very very important, ionization increases, very very important. And here in group ionization energy decreases by atomic size increases. So that's why what happened, it is what happened, very important, ionization energy decreases in group and it increases. Why it is increases? Because electrons enter into same shell. Suppose second orbit, same shell. So due to the size of the atom is decreases. So that's why in period what happened, it is what happened, increases, and in group what happened, decreases. So first group, it contains one electron, it is highly reactive. Suppose noble gases, so naturally they are more stable. Just what you call, I am explaining. So removal of first electron, how the situation, so these are what if apply, then automatically this is the order. So you can easily identify, already I explained. So see here hydrogen, so it contains only one electron. So here helium is stable, it contains only one electron, I explained, but it contains, it is a stable or unstable, if it is completely filled or partially filled, it depends on, all depends on what is that ionization energy and number of electrons. See here, if this is half filled and this is completely filled. So it depends on naturally what happened. Ionization energy. Half filled, more energy is required. Completely filled also, more energy is required. So across a period, sometimes you will ask which one is more stable and which one is less stable. He will ask a different type of question in different what you call competitive type of exams. So from this, my side, it is completed. Thank you very much. This is Dr. JMR. JMR chemistry. I explained in detail about ionization energy or ionization potential in group as well as in period. Thank you.